comparators. What do you mean by comparators? So the circuit which compares signal voltage applied at one input of op-amp with the known reference voltage at other input. That means you have a two input. In one input you are applying your signal. In another input you have some reference voltage. So this voltage will be compared with the reference voltage. If it is greater, you have a plus V set. If it is lesser, you have a minus V set. That's what they're trying to say. It is comparing the signal. Based on that, you will be getting your output. See, in the op-amp, when you take an ideal case, let me draw the basic op-amp. So inverting, non-inverting. Inverting means minus, plus means non-inverting. So here I will be providing the supply of 14 minus 14 here. So here is your output P0, loop gain, this open loop gain AOL. I am taking for open loop condition, right? Open loop condition into your potential difference. What is the potential difference? Potential difference is V1 minus V2. Why? V1 is connected in the non-inverting, V2 is connected in the inverting. That's why V1 minus V2. We know that in the ideal case, your gain is infinity. Now come to this diagram. This diagram for ideal characteristics. X-axis is your input and Y-axis is your output. You can see if input is greater than 0, you have a plus V set. If input is less than 0, you have minus V set. It is happening at the 0 crossing point. Exactly. 0 offset. But in the ideal case, in the practical case, this is for ideal case. But practical case, there will be some uncertainty. What do you mean by that? See, V0 equal to AOL V1 minus V2. So this will be finite, not infinite. So that means, see, there may be two cases, right? When VA is greater than 0, that will be plus V set. So I will take for first condition plus V set when VA is greater than 0. Okay, so AOL is finite amount of voltage. Let me take 10 to the power 5. Then V1 minus V2 I can take like a VD. It is a potential difference. So what is your VD? VD will be Vsat divided by 10 to the power 5. What is the Vsat? Let me take 14 10 to the power 5. So what you are getting? 140 millivolt. 140 millivolt. Similarly, if you calculate for second condition, minus Vsat 10 to the power 5 VD. What you will get? You will be getting VD equal to minus Vsat divided by 10 to the power, that is minus 140 millivolt. So what do you mean by that is, see, this is a point what you are derived, that is Vsat divided by your gain. Similarly, this point is called Vsat divided by minus Vsat by open level. When your input is less than this voltage, repeating again, if input is less than this voltage, your output will be linear. After that only it will go to the saturated output. When input is less than this condition, you will be in the linear way, that is uncertainty. So there will be some changes in the offset voltage that can be removed by introducing some offset techniques. But practically this will be there. This can be reduced. See, in the circuit it was shown for 2 millivolt. That means after the 2 millivolt only the output was changing. See, I have written here clearly the complete change in the output. The complete change in the output only after 2 millivolt. Up to that it was linear. Up to that it was linear, right? After that only you are going to the saturation region. This is the uncertain region. This is the uncertain region. Similarly here, up to minus V sat to AOL, you have a changes. After that only it was changing. After that only you are getting a plus V sat to minus V sat. So that is the difference between the ideal characteristics and the practical characteristics. So in the comparator, you will be having, if you are working in the open loop condition, first thing you want to remember, it can produce only two output. Either it can be plus VSAT, otherwise it can be minus VSAT. VSAT is nothing but your supply voltage. Minus VSAT is nothing but your supply voltage. You are providing positive supply and negative supply too. Right, so this is a basic property you should know about the op-amp and comparator principle. Okay, so same I explained you, right? Same whatever I explained before, na, it is given here also. So this is an uncertain region. So after this only you have a saturated output. Here also after this only you have a saturated output. So this is an uncertain region. This is an uncertain region. Okay, so that's what they're saying. So this can be removed. How? By providing some offset null compensation technique to eliminate this uncertain region. This can be removed. Not completely. I can reduce. If it is a 150 millivolt, I can bring to the 15 millivolt by adjusting or some introducing some technique in the circuit. Okay, x-axis is your input. I am repeating again. X-axis is your input and y-axis is your output. Okay, this is the basic you want to understand. Now let me start important about types of comparator. You have two types of comparator. Basically inverting comparator, non-inverting comparator. Very simple logic. Inverting comparator means I will be giving an input in the inverting term, that is minus terminal I will be giving. So you have a phase shift. You have a phase shift. But when you go for a non-inverting comparator, you will be providing the input in the non-inverting terminal, that is plus. So you don't have a phase shift. Don't have the phase shift. Okay, this is a basic condition you want to learn. Now we will move to the non-inverting comparator. See, in the non-inverting comparator, your input I have given in the input voltage I have given in the plus terminal. This is a non-inverting terminal. So reference voltage I have given in the minus terminal. Now what is, now I'll just see. Very simple, only two things you want to remember. So consider this is your applied voltage here. So I am taking a positive reference voltage. Two cases is there. One, I can take a positive reference, another can be negative. That is case 1 and case 2. Let me start with the positive reference. See, this is your VA. When VA is greater than your reference, it is greater, right? In this point is greater, na? So it is greater. So what is your output? Your output will be plus VSAT. Your output will be plus VSAT. Okay, so similarly if you take for this case the minus voltage, for this case VA, your VA is less than this reference voltage, or this is a reference voltage Vref. For this minus signal, that is a reverse signal, negative sine wave is less than your reference voltage. So you have a minus VSAT. So you have a minus VSAT. Understand? So minus VSAT. That's all. See, I have given very clearly. When VA is greater than Vref, you have a plus VSAT. You have a plus VSAT. When VA is less than Vref, you have a minus VSAT. That's all. So in the plus terminal, that is a non-inverting, I am feeding the time varying signal. In the negative terminal, I am giving the fixed some reference voltage, that is given as a Vref. In the subscript it was given ref. Ref mean by reference voltage. Let me go to the diagram. So two cases I am going to describe now. One is the case 1, this is the case 2. In the case 1, I have fixed a reference in the positive. In the case 2, I have fixed the reference in the negative. That's all. See here, when VA is greater than VREF, you have plus V set. So this is your reference voltage. So in this point, surely it will be in the minus V set only. Da? See, from here only this condition will work. From here only plus V set. So before earlier of this condition will be minus V set. So that's what is given here. Minus V set. Similarly, when VA is less than VREF for negative, let me say for this one, for this voltage, this is your VA, for this is a rough V rough. This voltage is less than this one, so I can write VA is less than V rough, so you have a minus V set. This is plus V set, this is a minus V. See, it is given clearly. VA is less than V rough, you have minus V set. When V is greater than V rough, you have plus V set. That's all. Similarly, here also, only thing difference in the case 2 is I have fixed in the reference in the negative. That's all. So similarly, when your reference voltage is less than 0, because it is in the reference, it is in the negative side, right? So when VA is greater than reference, see, surely this VA is greater than VREF, so you have a positive V set. When VA is less than, for this voltage, this is lesser, right? So this is higher, reference voltage is higher, right? So that means you have a minus V set. That's all. Very simple to remember these two conditions. So here same circuit only. There are some we have some few modification. Like we are providing a case 1 and case 2 separately, right? So here I have connected one potentiometer. By adjusting the potentiometer, I can vary the reference voltage like from plus to minus. So this is a practical circuit from which I can design your comparator in the real time system. It is a non-inverting comparator. So this is something like a voltage divider. Here something like a voltage divider with 10 kilo ohm potentiometer, which is connected between the V plus and V minus. So your time varying signal is you are given in the plus terminal. Okay, this is a practical circuit. The previous was ideal circuit. Okay, now let me go to the inverting comparator. So already I explained you the inverting comparator. We will be provide your input signal in your minus terminal. You can see now I have given my input in the minus terminal, that is your time varying signal. Your reference signal I have given this minus voltage, minus ref here. Here I am giving a plus ref here by adjusting the potentiometer. By adjusting this potentiometer, I can change plus and minus reference voltage. So VA is applied in the minus term, that is your inverting terminal. So whatever you are giving input, that will be a reverse. Okay, that is opposite to the previous condition. See, in the previous condition, what we have considered, when V is greater than Vref, you have a plus V set, right? Here in the inverting, that was opposite. When VA is greater than Vref, V0 will be minus V set. That's all. Because input is given in the minus terminal. When V is greater than Vref, your output will be minus V set, because I have given the input in the minus terminal. So that is the basic logic that you learned in the previous classes. When VA is less than Vref, your output will be plus V set. That's all. The logics, everything is same. Okay, that is given clearly here. See, similarly, you have two cases. One is a positive reference and is a negative reference. In the positive reference case, when this is a VA is greater than reference voltage, so you have a minus V set. I will set clearly now, so I will write the condition again. When VI is greater than Vref, you have a minus V set. When VA is less than Vref, you have a plus V set. That's all. Very simple. See. So you can see here, this is a minus V set, this is a plus V set. Similarly, here I have fixed the reference voltage in the negative side. When V is less than minus Vref, you have plus V set. When V is greater than minus Vref, you have minus V set. This is a basic property of comparator, inverting and non-inverting. In inverting means you are providing the input in the minus terminal. Non-inverting means you will be providing the input in the plus terminal. So based on that condition also varying, that everything we discussed in this class. Right. So this is a next circuit. So by so this is some, they have modified the basic circuit. Suppose I want to limit your output. So during that condition, I can add the Zener diode in the across a resistor, so I can limit your voltage in the output. So if you want to limit the voltage in the output side, I want to get like a 9.7 or minus 9.7, so in that case I can connect the Zener diode. Okay, during when I'm giving the like a positive, your VZ will work. When I'm giving the negative cycle, your VZ2 will work. So you'll be having a plus 9.7, here you'll be having minus 9.7. So the basic concept is the limiting voltage of V0. That is why we are connecting the Zener diode in the output side. So that is a very important point, the limiting voltage of V0.